and I'm the first vice president, soon to be president of the Canadian Society for the History and Philosophy of Science. And I was asked by Alan Richardson to introduce our Drake lecture today. So it's my enormous pleasure to do so. Our Drake lecturer for this year is Professor Deborah Coen. Dr. Coen comes to us from Yale University, where she is professor and chair of the History of Science and Medicine program. And as many of you know, the Drake Lecture was named for the eminent historian of science, Stillman Drake, whose groundbreaking translations and analyses of Galileo's work changed the very way we understand Galileo and his physics of motion. And this lecture honors Drake's influence in the history and philosophy of science. And in this case, we were fortunate to have a speaker who not only, in my opinion, is a marvel of productivity, versatility, and broad thinking, but also of the potential for historical work to shed light on some of the most pressing issues of our time, but more on that in a moment. So Dr. Coen began her intellectual life in the physical sciences, earning her undergraduate degree in physics at Harvard University in 1997. And from there, she moved to Cambridge University, earning an MPhil in history and philosophy of science, after which she returned to Harvard and graduated with her doctorate in 2004, and also where she was a junior fellow in the Harvard Society of Fellows. After this, Dr. Coen spent over a decade teaching history at Barnard College at Columbia University, where she also was director of research clusters at the Columbia Center for Science and Society. Dr. Coen's early work focused on modern Central Europe, particularly in the 19th century, and her first book, entitled Vienna in the Age of Uncertainty, Science, Liberalism, and Private Life, was published in 2007 and used the Exner family as a window onto the science and politics of fin de siècle Austria. And this work earned Coen the 2008 Barbara Jelavich Book Prize from the American Association for the Advancement of Slavic Studies, the 2008 Austrian Cultural Forum Book Prize, and the 2007 Susan Abrams Prize from the University of Chicago Press. Coen's 2013 book, The Earthquake Observers, Disaster Science from Lisbon to Richter, examined seismology's history as a form of citizen science, a production of non-expert observers, and moved her closer to the realm of environmental history. More recently, Dr. Coen's focus has shifted to the production of environmental knowledge, in particular by scientists who focus on climate. Her most recent book, Climate in Motion, Science, Empire, and the Problem of Scale, published in 2018, was winner of the 2019 Pfizer Prize from the History of Science Society, and it explores the study of climate prior to the computer age. Most recently, Coen is modeling humanistic scholarship that reaches across the divide between the sciences and the humanities and promises to contribute in novel ways to the multidisciplinary conversations that are required to address anthropogenic climate change. Her talk today is entitled Degrees of Vulnerability. Please join me in warmly welcoming Dr. Deborah Coen.
Thank you so much for that introduction, Tara. And it's really nice to see some old friends in the audience here. I'm going to try sharing my screen. So like many historians at this point in the pandemic, it has been a long time since I have stepped foot in an archive. Instead, I've been trying to build my own. So the project I will outline here grows out of a series of interviews I've been conducting with researchers working at the intersection of the natural and social science of climate change. These interviews now number around 30. In them, I've tried to draw out the researchers' own experiences of vulnerability, their personal awakenings to the threat of climate change, their strategies for coping with the uncertainties of scientific knowledge, their reactions to criticisms, their responses to the challenges that doing solution-oriented science poses to traditional academic careers, and the networks of collaboration and mentoring that have sustained them. Alongside this foray into recent history, I've become fascinated by historical meteorological instruments, exploring Yale's collection with the help of the amazing Alexi Baker and in the company of undergraduate students in my Making Climate Knowledge class. So my presentation is going to be an experiment in placing the 1770s and the 1970s into conversation with each other. I'll add that as a historian of the 19th century, I do so with some trepidation and in the hope of learning from those who know a lot more about these eras than I do. I begin with a simple observation and question. The study of climate change and its impacts necessarily involves knowledge of vulnerabilities, one's own and those of others. But what kind of a scientific object is human vulnerability? So over the past 2 decades, the concept of human vulnerability to climate change has become foundational to both academic research and movements for climate justice. Among scholars, policymakers, and activists, this concept serves a number of purposes. It functions as a conceptual tool for understanding the dynamical interactions between the Earth's climate and ecological and social systems. It informs the setting of targets and limits for greenhouse gas emissions. It supports work towards climate justice by shifting research and resources to the, quote, most vulnerable populations. It helps identify appropriate adaptation strategies to reduce risk to those groups, and it supports legal action against greenhouse gas emitters through estimates of loss and damage. Yet definitions of vulnerability vary, as do methods to assess it. Note in these examples the different scales of the maps and the different purposes of the calculations. And these different methods lead, as you can see here, to different results. The darker places on the map are the ones where estimates of vulnerability diverge most. Some measures of vulnerability start with model-based predictions of impacts, while others start from socioeconomic indicators. Measures of vulnerability are also highly scale dependent, such that aggregating data across scales introduces ambiguities. How does the vulnerability of the household relate to that of the region or the nation? Moreover, the concept of vulnerability today is itself vulnerable to powerful critiques. To some progressive critics, the concept is ill-suited to conversations about justice. Some charge that it pathologizes the poor and denies their agency. Others that it naturalizes social injustice and favors technical over political solutions. Other critics warn that conflicting interpretations of vulnerability are derailing international negotiations over climate mitigation and the funding of adaptation. Recently, economists have revealed that those who most need international funds to adapt to climate change have the most trouble securing those funds. This is in part because applicants are often required to supply up to 30 years of climate impact data, a huge hurdle for countries lacking the necessary scientific infrastructure or where observations have been disrupted by conflict. The Liberian representative to the UN's Green Climate Fund recently accused the fund of allowing, quote, people to die because they don't have the data. As I will elaborate later in this presentation, I agree with these critics that the concept of climatic vulnerability as it exists today is inadequate to the work of climate justice. In the larger project that I will outline here, and which I am just beginning, my aim is to use the history and philosophy of science to think through the epistemic and ethical challenges of measuring climatic vulnerability. The history of atmospheric measurement has typically been written as a progression towards standardized instruments that register a handful of meteorological elements. Instruments designed to circumvent the complex responses of living bodies to the vagaries of the atmosphere. Since the 19th century, this process of reduction has generated scales of atmospheric risk shaped by the ideological demands of colonialism, slavery, and international finance. Our histories of measurement tend to tell a teleological story in which disagreements are disagreements only about which instruments and which units to use. So my method, in brief, is to recover the stakes of disputes over how to measure the atmosphere, attending to the friction that modern frameworks of differential vulnerability generated at the moment of their introduction in the late 18th century. In 1779, Jan Ingenhousz chose to take the long way home. A year and a half in England had not left him any fonder of the formalities of the Habsburg court, where he served as physician to Empress Maria Theresa. In London, he had dined regularly at the Club of the Royal Society, discussing the latest theories of electricity and the chemistry of gases with luminaries like Joseph Priestley and John Pringle. But the scientific questions that thrilled him most had lured him to the countryside, to a house with a garden and all that his research required: fresh air, fresh water, vegetation, and sunlight. It was there that he had finally mastered a new and notoriously temperamental measuring instrument. The eudiometer was literally a gauge of the goodness of the air. It promised to allow skilled men of science to assess the purity of the air they breathed at any location at any point in time. With this apparatus in tow, Ingenhousz was in no hurry to return home to Vienna. A detour through the Low Countries would allow him to visit his family and check on business ventures, and to learn something he was burning to know. He planned to apply his eudiometer all along the North European coast and across several of the principalities that made up the Habsburg Swampy Empire. Already, Ingenhousz had a vision of the information he would carry home from this journey, a clearer sense than ever before of the variations of the atmosphere, from the purest, healthiest sea air to the most putrid, toxic miasmas. As a physician, he suspected that his instrument might well echo the wisdom of generations of patients and medical men documenting the benefits of sea air. But he also trusted the simple assemblage of glass vials and tubes to alert him to the shortcomings of common sense. Here at last was an instrument with the potential to judge more finely than the most experienced physician which locales could truly be called helpful. Air played multiple vital roles in the 18th century. The progenitors of the science of eudiometry were typical of their contemporaries in thinking of air as simultaneously a nutrient, a medicament, a stimulant, and a constituent of living things. In plants, the motions of the atmosphere made up for a lack of muscles. The wind that rustles a stem was said to have, quote, the same effect on the liquor of plants as the action of the muscles on the liquor of animals. 18th century botanists likened plants to the tubes and vessels of pneumatic science, optimally designed to facilitate airflow. Like plants, animal bodies were porous to the atmosphere. As John Brown put it in his influential Elements of Medicine, pure air provided a salutary stimulus that was a necessary part of many medical cures. The controversial materialist, Julien Offray de la Métrie, explained that lungs were to animals what leaves were to plants, while heat was nature's other heart, causing juices to circulate in the tubes of plants, which breathe as we do. In all these ways, tracking the flow of air in and between living bodies underscored the affinities between plants and animals. In retrospect, Ingenhousz's eudiometric quest appears to foreshadow our own world. Today, the science of climate vulnerability wields vast influence. Global health experts track the spread of diseases as regions warm, floods increase, and air becomes harder to breathe. No prudent business person would consider investing in construction on a low-lying island or coast without first consulting calculations of risk from floods and storms. It's tempting to interpret Ingenhuse's investigations as a forerunner of this research program. In the 1770s, the eudiometer promised to make possible a precise calculation of atmospheric risk. Such a formula would be of tremendous use in the age of reason. The officers of the East India Company, for instance, would surely want to consult those tables before settling on any new settlement ventures. They might likewise guide the pricing of the new insurance policies that Ingenhus had seen advertised in the English papers. An instrument able to measure the virtue of the atmosphere inspired overwhelming optimism among 18th century entrepreneurs. But Ingenhus was not one to put much stock in such schemes. To be sure, he had a wide reputation as an innovator. At a time when vaccination was still a novel and suspect practice, he was famous throughout Europe for having successfully inoculated the Austrian royal family against smallpox. Still, in his medical practice, as in everything else, he was circumspect. Traveling from London to Vienna was more than enough for him. He had no interest in trying his fortunes overseas. After one embarrassing loss to an American con artist, his investments were prudently confined to mining ventures close to home. Nor did he buy into the new logic of risk that the insurance industry was promoting. Privately, he suspected that life insurance was a foolish business. In short, he was an old-fashioned type. What he saw from experimental science was not fame and power, but a clearer view of God's design of the natural world in all its wisdom. In these respects, he had to admit he was well suited to Vienna, capital of the largest Catholic land empire of its day, with hinterlands that still retained vestiges of feudal customs and noblesse oblige. Indeed, it worried him that the Viennese seemed to be depleting their forests, those preserves of healthful air. In all, Ingenhus was content with the life he knew. Though he grumbled about courtly pomp, he was pleased to be a favorite of a powerful monarch, well-housed and well-fed. Which may be why he was not overly disappointed when his eudiometer failed to produce the clear indications of good and bad air that he had anticipated. Priestley had begun to charge that the instrument was unreliable. Even his dear friend Felice Fontana, who had taught Ingenhus to operate a eudiometer during their time together in Paris, even Fontana reported that the instrument's measurements were not quite trustworthy. The Italian physicist suspected that variations of the atmosphere from one location to another were outweighed by the changeability of the air over time. With this, Ingenhus agreed. Why, he wondered, did critics assume that this changeability indicated a fault of the instrument rather than, quote, the real changes happening in our element? Ingenhus reasoned that the air was subject to, quote, continual alterations from a variety of causes. As examples, he pointed to heat and cold, dryness and moisture, light and obscurity, winds blowing from different quarters and conveying airs of different qualities from distant countries, as well as a great number that are perhaps not to be traced by human sagacity. Though he hadn't expected it to work this way, the eudiometer revealed to him a natural world in constant flux. Quote, the constitution of the atmosphere remains seldom a whole day the same, and the degree of salubrity is constantly changing. The eudiometer could serve more than one purpose, Ingenhus observed. Personally, he was keener to use it, quote, to trace nature in the operation of vegetables than to examine the degree of salubrity of the common air. In the Dutch physician's hands, the eudiometer became a tool to find evidence of divine providence in the relationships among plants, animals, and their material surroundings. Hence his interest in what he called squeezing the air out of vegetables. His eudiometer told him that different vegetables released different kinds of air, different still, as he put it in his inimitable English, from the air, quote, with which we ease ourselves from the rectum, perhaps after digesting some of those very vegetables. He surmised that these differences arose from changes occurring during the process of release, rather than differences in the air contained within living things. It was clear to him that these changes were part of a universal natural cycle, a cycle of kinship between humans, animals, plants, and minerals. Just so, he explained, an animal body becomes a manure for plants by corruption. It changes thus in the substance of a vegetable. This being burnt changes into ashes, which by the action of the same fire and by the addition of some sand and some calx of lead changes into fine transparent glass. Thus, what is now a part of our body may become in a short time a part of a pot or a bottle. Comparing a person to a pot was not as outlandish in the 1770s as it would be today, given the analogies in play between plants, animals, and machines. Whether made of metal, ceramic, wood, or glass, Ingenhousz reminded his readers, instruments and bodies were ultimately the same stuff, and therefore subject to the same idiosyncrasies and changeability. Ingenhousz knew, perhaps from his teacher Peter van Musschenbroek, an early materials scientist, that the behavior of materials, organic and inorganic, often varied with their place of origin. Climate and soil shaped the stuff of which instruments were built, just as these factors shaped living organisms. It was for this reason that a eudiometer could serve an essential purpose, even if it could not be calibrated in absolute degrees. Precisely insofar as it resisted attempts to standardize it, the device's responsiveness to the atmosphere exhibited idiosyncrasies that spoke of the atmospheric sensibility of matter in all its forms. Ingenhousz's critics, men such as Priestley and Humboldt, insisted that measuring instruments were or should be transparent windows, allowing nature to write itself in its own universal language. Ingenhousz instead approached instruments as bodies akin to his own, responding to the atmosphere in unique yet intelligible ways. It's possible, in fact, that many debates circa 1800 over the reliability of meteorological instruments can be interpreted as confrontations between these two frameworks: the belief that nature speaks through instruments in one universal language, and the belief that each instrument or a class of instruments speaks its own language. More generally, Ingenhousz's life illustrates the friction between two ways of thinking about what we do when we measure the world, the atmosphere in particular. These two frameworks coexisted then and still persist today, and yet historians have rarely noted the conflicts between them. The first of these frameworks is sensibility. Sensibility denoted the capacity of matter or mind to respond to stimuli from the world. It was a propensity to be affected, whether physically, mentally, or emotionally. Sensibility in this sense was equally a virtue of natural philosophers and a property of every organism, definitive of their capacity to seek out light, warmth, and nourishment. According to the empiricist philosophy of the 18th century, sensibility was the starting point for all we know of the world, whether through common experience or scientific investigation. It explained both the diagnostic skill and the human sympathy of a physician like Ingenhousz. Sensibility was also understood to take pathological forms. By the early 19th century, medical men regularly invoked pathological sensitivity to atmospheric fluctuations as a means of justifying slavery and naturalizing hierarchies of race and gender. This emphasis on degrees of sensibility, which finds clear echoes today in indices of vulnerability, gradually displaced the 18th century emphasis on receptivity to atmospheric influence as a common property of living things. The second way of thinking about atmospheric measurement revolved around the notion of risk. Risk is a measure of expected losses due to a particular threat. Within the framework of risk, the purpose of measurement is to discern regularities that can help rational actors to manage the uncertainty of the future, whether through material defenses or financial strategies. As Francois Ewald has argued, the concept of risk was a product of the insurance industry. It expressed the conviction that measurable, randomly distributed events could profitably be insured. Sensibility and risk also carry different implications for how people relate to each other. Although Ewald finds risk thinking to lie at the heart of the 20th century social welfare state, risk initially pinned moral responsibility on the individual. Buying insurance was a way to demonstrate self-reliance. True, one thereby became part of a new collective, the circle of policyholders. But as the insurance industry grew, so did the anonymity of this group. Sensibility signals interdependence rather than dependence. It acknowledges that living things, though unequal in power, rely on each other for survival. From a sensibility perspective, responsiveness is complex, not just in a causal sense, but also in a moral one. Whether the response is positive or negative is not easy to say. It may be painful yet productive, both a source of suffering and a source of learning. In these respects, sensibility squared well with a tendency among early modern Europeans to look to the social order, to traditional obligations between the powerful and the powerless, for what was commonly called security, that is, for protection against future unknowns. Of course, such norms were only as reliable as the individuals who upheld them or chose not to. Historians disagree over how much protection feudal norms afforded peasants when crops were hit by drought, floods, hail, or infestations. What is clear is that many 18th century Europeans, particularly in the lands east of Vienna, trusted these traditional social arrangements as security against a range of hardships, more than they trusted insurance policies against a single threat. As frameworks of interpretation, sensibility and risk pushed atmospheric measurement in different directions. Risk targets a narrow class of objects: hailstorms in Carinthia, fires in Saxony, wheat rust in Lombardy. Sensibility instead casts a wide net for observation, making it difficult to arrive at neat one-to-one correlations. While risk dictates a statistical, algorithmic science of frequencies, sensibility calls for a holistic science of complexity. Measurement meant different things according to these different outlooks. By the 19th century, risk dominated the science of the atmosphere. Colonial markets drove demand for simple indicators to help crops thrive far from their native environments. These could tell gardeners how warm to keep their greenhouses, even if they couldn't guarantee success. The insurance industry sought out meteorological measurements to price hail and crop insurance. Insurance companies had no time for the complex responsiveness of plants to atmospheric variability. They wanted neat tables of the degree of sensitivity of different crops to one type of hazard, whether hailstorms or early frost. The reductionism of 19th century meteorological measurement also served defenders of colonialism and slavery by naturalizing racial hierarchies in terms of degrees of environmental difference. Back in the 1740s, La Mettrie could still phrase environmental determinism in qualitative terms. Quote, "One people have a heavy and stupid mind, another a lively, light, and penetrating one, from the food they eat, their father's semen, and that chaos of diverse elements that swim in the immensity of the air." By the 1850s, such claims required quantitative data. These new political and economic incentives put pressure on the design and use of meteorological instruments. The goal became to isolate easily standardized elements of the atmosphere, above all temperature and pressure. Indeed, from the 1840s, there was a sharp rise in publications containing the phrase atmospheric elements. Travelers invested in thermometers and barometers, neglecting other instruments that were trickier to standardize and correspondingly responsive to subtler changes of the atmosphere. The aim of my project then is to explore the ambivalence of Ingenhousz and many of his contemporaries towards this reframing of the purpose of atmospheric measurement. I want to make clear that neither sensibility nor risk is a conceptual framework adequate to the work of climate justice today. Both concepts are laden with assumptions that have served to legitimate colonial and capitalist exploitation. However, tending to the friction between these frameworks in the past may help us imagine what a genuine vulnerability science could look like in the future. At this point, I propose to leave Ingenhousz behind, I'm afraid just as the French Revolution is about to upend his life. I want to move ahead 200 years to the 1970s, where we'll find that scientists were just beginning, after a long hiatus, to ask many of the questions about the influence of the atmosphere that Ingenhousz and his contemporaries had tried so hard to answer. For much of the 20th century, observers in industrialized nations had taken little interest in these questions. Wealthy countries had forgotten the experience of famine. Ample fuel for heating, combined with technologies of air conditioning and refrigeration, made it easy to believe that humanity had become immune to climatic variability. What's more, the drought-resistant seeds of the Green Revolution made it seem a safe bet that the 1970s would see a global decrease in human vulnerability to climate. Then came the oil embargo and the perception of an energy crisis in much of the industrialized world, followed by the 3 Mile Island accident, which spelled the political death of the nuclear alternative to fossil fuels in the US. And then there was the weather. In the early 70s, many West Africans faced a devastating drought. Peruvian fisheries saw the collapse of the anchovy population, and the USSR was forced to import grain after the failure of its harvest. Unexpectedly then, the 1970s became the decade when industrialized societies first confronted their own vulnerability and began to pose the question of whether development might actually be increasing the vulnerability of poorer nations. Among the vulnerabilities that wealthy nations were forced to confront in the 1970s were the effects of anthropogenic global warming. In 1979, the first World Climate Conference resolved to prioritize research to, quote, determine the characteristics of human societies at different levels of development and in different natural environments, which make them especially vulnerable or especially resilient to climatic variability and change. What did vulnerability mean to these experts? At the time, a quantitative concept of vulnerability existed in multiple fields: operations research, risk analysis, communications engineering, hazards research, and systems ecology. In all these fields, vulnerability meant the propensity of a system to break down in response to an internal or external threat. This is the sense in which vulnerability was introduced to the science of global warming as a systemic property, whether of a rice crop, a dam, or a city. Hazards researchers like to say that a system was only as strong as its weakest link. This quip illustrates a shortcoming of the systemic concept of vulnerability. It fails to describe socio-environmental systems that thrive at the expense of the weakest. System theoretical interpretations of vulnerability in the context of development reflected the fortress mentality of the Cold War. Development experts rarely commented on the fact that the concept of vulnerability was used to justify military aggression and the suspension of civil liberties. Already then, there were hints that vulnerability would have to be redefined for application to climate change. The field of hazards research had defined a population's vulnerability by holding the magnitude of the hazard constant while measuring variations in response across social units and over time. Hazards researchers measured the magnitude of an earthquake or the wind speed of a hurricane and compared these numbers to damage on the ground, such that excess damage was the index of relative vulnerability. Epistemically then, vulnerability connected biogeophysics with social science, and morally, it mediated between empirical and normative questions. But a hazard is a discrete event, while global warming is not localizable in space or time. Climate is not a simple variable that can be held constant observationally for the sake of comparing impacts at distinct locations or different historical moments. Hence some of the profound ambiguities that still plague measures of vulnerability today. Given the many hazards associated with climate change, does a population's vulnerability vary with respect to different hazards? Or is vulnerability a function of underlying social conditions, irrespective of a given hazard? The problem of measuring climate vulnerability has thrown into relief some of the unique challenges that global warming poses to the methods of modern science, or more precisely, to the workarounds that science falls back on when facts and values collide. Reckoning with climate change would mean rethinking the scientific meaning of human vulnerability. That process was sidelined in the US and UK in the 1980s in the face of resistance from the Reagan and Thatcher administrations. The study of climate impacts, particularly the societal impacts of increasing climatic variability and extremes, which is now categorized as the science of adaptation, was widely stigmatized in the 1980s as a moral hazard. Concerned scientists and policymakers believed that attention to adaptation would seed complacency and deflect attention from the urgent task of mitigation. In the Anglo-American world of climate science and policy in the 1980s and 90s, few were talking about vulnerability. And in passing, I should note that some of the most important research on this topic in those years was carried out at Canadian universities. The drive to rethink the concept of vulnerability came instead from the global feminist movement. In the 1980s and 90s, liberal feminists of the global North entered into dialogue with Indigenous and global South feminists, and together they began to remake the broad concept of vulnerability. In the hands of hazards and development researchers, vulnerability had been a stigma projected onto populations who had no say in its definition. Global feminism called for a reconceptualization of vulnerability and invited a diversity of voices into the debate. Vulnerability was theorized in this period by loosely linked communities of feminist thinkers. Indigenous feminists like Sheila Watt-Cloutier, Deborah McGregor, and Robin Wall-Kimmerer, Global South feminists like Vandana Shiva, Chandra Mohanty, and Val Plumwood, liberal feminists like Martha Nussbaum and Amartya Sen, and eco and queer feminists like Carolyn Merchant, Judith Butler, Jana Haraway, and Karen Barad. Watt-Cloutier, for instance, as chair of the Inuit Circumpolar Council, pointed out that the UNFCCC had not even mentioned the Arctic as an area vulnerable to climate change. She and other Indigenous activists do not simply add the Arctic to the list of vulnerable regions, they helped to redefine the meaning of vulnerability. She insisted that those who were vulnerable, including Indigenous women, be recognized as keepers of relevant knowledge. As she put it in testimony to the US Senate in 2004, our elders and hunters have intimate knowledge of the land, sea ice, and have observed disturbing changes to the Arctic climate, environment, and wildlife. Subsequently, Indigenous feminists like Kimmerer and McGregor began to push back against the tendency to distort Indigenous knowledge to fit Western epistemological frameworks. To take another example, Martha Nussbaum's moral theory posited vulnerability as the very foundation of human excellence. She broke with the Kantian assumption that for an action to be moral, it must be a willed act, independent of external contingencies or luck. Instead, she argued that the potential to live a good life begins with attachments to ephemeral objects and circumstances. That is, the good life grows from vulnerabilities. Human excellence, she wrote, is something whose very nature it is to be in need, a growing thing in the world that could not be made invulnerable and keep its own peculiar fineness. This insight in part led her to ask whether the conditions for a good life could be universalized to protect the rights of poor women in the global South. Although Nussbaum did not align her argument with environmentalism, the image with which she opened her study, drawn from the ancient Greek poet Pindar, was that of human excellence as a growing vine, vulnerable to weather. The excellence of a good person is like a young plant, something growing in the world, slender, fragile, in constant need of food from without. A vine tree must be of good stock if it is to grow well. And even if it has a good heritage, it needs fostering weather, gentle dew and rain, the absence of sudden frosts and harsh winds, as well as the care of concerned and intelligent keepers for its continued health and full perfection. Now, I think it's telling that Nussbaum overlooked certain ambiguities in this image. Doesn't transferring the notion of good stock from plants to people raise some ethical concerns? Who is to judge whether the plant's keepers are behaving intelligently? Note too that what might be fostering weather for some plants would be poison to others, right? No cactus is going to flourish thanks to persistent gentle dew and rain. I think these silences illustrate some of the dangers of theorizing vulnerability as a universal condition, full stop. Reacting against the universalism of liberal feminists like Nussbaum, Judith Butler framed the attacks of September 11, 2001 as an opening to a radical new form of global feminism. Butler insisted that the experience of vulnerability among the privileged could and should catalyze a transnational counter-imperial feminist politics. In Precarious Life, she asked, could the experience of a dislocation of first world safety not condition the insight into the radically inequitable ways that corporeal vulnerability is distributed globally? Now, the question Butler raised and continues to explore concerns the gap between apprehending vulnerability and taking responsibility for it, which is precisely the gap evident from inaction on climate change. In a loose sense, these feminist reinventions of the concept of vulnerability have helped to shape research on climate change over the past 2 decades. This has been accomplished by a network of feminist scholars trained in geography and political science, a group that includes Diana Liverman, Susan Cutter, Karen O'Brien, and Maria Carmen Lemos. One example of this research is the Social Vulnerability Index, introduced by Cutter and her collaborators in 2003, and used, for instance, by the US Federal Emergency Management Agency to identify communities most at risk to climate hazards. The influence of these feminist researchers is evident in the most recent IPCC publication, Working Group 2's contribution to the 6th assessment report, which came out in February. The report foregrounds global inequality and highlights, quote, the role of social justice in diverse forms of knowledge, such as indigenous knowledge and local knowledge. And yet, feminist theory also helps us see the limitations of these newer concepts of vulnerability as tools for climate justice. So let me single out 5 effects of applying these newer measures of vulnerability. First, any definition of vulnerability inevitably constitutes a value judgment, since it dictates what merits protection. Most vulnerability indices factor in only economic loss and loss of life, ignoring the value of local and indigenous cultures and forms of knowledge. This imposition of values is compounded by the UN's Green Climate Fund and other lending institutions which decide which forms of adaptation can go forward. Second, in practice then, vulnerability is often little more than a stand-in for risk to potential investors, a form of credit rating. This usage draws a line between the active members of society who have the capacity to manage risk and those who are passively at risk. It imposes a stigma. 3, erasing history. Attaching the label vulnerable to certain populations without offering any historical context implies that greater vulnerability is an inherent characteristic of that population. As Angela Harris writes, quote, "The language of vulnerability is often used to obscure the social and political roots of that vulnerability. In other words, talk of vulnerability can elide the moral responsibility of those who have benefited from systems of oppression." 4, idealizing invulnerability. Scales of vulnerability, like those used by the IPCC, can also perpetuate the assumption that the ultimate goal is invulnerability. This discourse encourages the privileged to disavow their own vulnerability, displacing it onto others. 5, generating apathy. In that way, treating vulnerability as a simple scalar quantity and mapping it onto distant populations can lead to apathy among the privileged. In her recent book, Psychological Roots of the Climate Crisis, the psychoanalyst Sally Weintraub explains climate denialism as a disavowal of vulnerability in this sense. She argues that many denialists have a narcissistic inability to tolerate evidence of their dependence on other people and on the physical environment. Refusing to acknowledge their own vulnerability, they resort to denial, including the denial of scientific evidence. For this reason, feminists propose that we recognize a wider meaning of vulnerability, one that is not inevitably about harm. They interpret vulnerability more capaciously as an openness to being affected in unforeseeable ways, perhaps negative, perhaps not. From that perspective, vulnerability is a form of agency rather than passivity. It is a starting point for knowledge and for solidarity. The point is not that we should celebrate vulnerability. On the contrary, vulnerability takes forms that are unjust and must be redressed. Rather, as philosopher Erin Gilson puts it, the point is to recognize our own vulnerability as a fundamental condition with which to reckon, a reckoning that has the potential to inspire new forms of alliance. For legal theorist Angela Harris, vulnerability describes not just interdependence among humans, but also human interdependence with the non-human world. It therefore has the potential to ground a politics that reconciles social justice and environmental sustainability. But Harris also warns that a universalized concept of vulnerability can deflect attention away from inequalities. Quote, "Misused, vulnerability analysis can make power relations and therefore injustice invisible." Where does this leave climate science? Some of these theorists, most notably the trained physicist Vandana Shiva, have been explicitly hostile to science, seeing it as exemplary of the fantasy of invulnerability. Others, including the psychoanalyst Weintraub, describe recent developments in the natural sciences, such as the turn to interdisciplinary and participatory research, as a model of what Gilson calls epistemic vulnerability, a way of knowing that relinquishes the fantasy of omnipotence. What then would a genuine vulnerability science look like? Following Gilson, the operative question is how such a science would represent vulnerability, or more specifically, how its representations of vulnerability would invite a viewer to respond. Gilson takes pornography as a case study. Under what circumstances does pornography encourage viewers to distance themselves from the vulnerable, to project their own vulnerability onto others? How might pornography instead provoke awareness of vulnerability as a shared condition? Cognitive awareness is not enough, she insists, since expressions of sympathy often accompany the drive for invulnerability. The representation of vulnerability must be able to subvert social divides and foster new alliances. Gilson offers examples of feminist pornography that succeed in this effort by encouraging responses that transgress normative identities. Following Gilson, we might ask, only partly tongue-in-cheek, what can scientists learn from pornography? To answer this, let me turn to a new book by the anthropologist Sarah Vaughan, an ethnographic account of climate adaptation research in coastal Guyana. Nothing pornographic here, sorry to disappoint. In one chapter, Vaughan describes how Guyanese researchers distribute water filtration kits to residents of an increasingly flood-prone area, an area that is home to communities that have historically defined themselves against each other, racially and politically. The researchers acknowledge that neither they nor the locals can foresee all the purposes that the water filtration kits might serve in the future. In this form of participatory research, expertise thins out in Vaughan's terms. In the context of the racial politics of Guyana, this research avoids definitions of vulnerability that embed existing racial hierarchies. It is instead an opening to new alliances, what Vaughan calls counter-racial world-making. These water filtration kits are not transparent instruments, not windows onto a passive world, not tools for a quick fix. Rather, the kits hold multiple potentials for multiple ways of knowing. Vaughan's example suggests that a genuine science of vulnerability will treat measurement as what Karen Barad calls interaction, entangling the observer with the observed. Following the example of Ingenhuth and his contemporaries, I'll propose instead an organic metaphor for such an act of measurement. A spider sitting in its web, sensing tensions throughout its fibers and adjusting accordingly. Not coincidentally, 18th century experimenters didn't take the ropes and cords that moved their machines for granted. Organic fibers, they knew, responded to the atmosphere in complex ways. Like a spider's web, tools for the study of vulnerability should make palpable the webs of interdependence, physical, organic, and social, that support and constrain human existence. Thank you.
Thank you so much, Deborah, for a very fascinating talk. I just have to apologize. Oops, and you can see me. I have to apologize. I have some work being done on my kitchen, so I apologize for any background noise. So are there any questions or comments? You can use the raise your hand feature. Oh, there we have. Yes, Jennifer.
Hi, can everyone hear me? Awesome. Okay, it's a question, but it's not a super well-formed question. First of all, thank you so much. That was fascinating, and I have a lot of thoughts. And I guess I'm wondering if you can speak a little bit more about this 18th century idea of instruments as being vulnerable to or sensitive to the atmosphere that they are meant to measure. And if I'm understanding correctly, how or whether that idea might be useful as we're thinking about 21st century's models of vulnerability and thinking about the model as part of and responding to the climate that we are measuring in the environment that we're in, as opposed to like kind of trying to reach for a view from nowhere sort of picture.
Yeah, I mean, you put that beautifully. thank you for helping me think it through, since this is really the first time that I'm trying to articulate this. You know, I certainly don't mean to say that we don't need quantitative measurements. Clearly, part of climate justice depends on those measurements, on financial calculations, according to calculations of risk. But clearly, justice also requires something more, right? Because to reach out to for elite scientists to reach out to vulnerable populations in this stigmatizing way that is often a disavowal, right, of common vulnerability, is really insufficient as a part of the quest for justice. So what I'm looking for is a way to reimagine, right, the way that vulnerability is represented in the process of measurement. And I think that the 18th century is suggestive insofar as these natural philosophers are so deeply attuned to that sensibility of inorganic as well as organic matter, right? To their affinity within organic matter, that perhaps there is a clue in there that can help scientists today achieve the kind of epistemic vulnerability that Erin Gilson is describing, that the kind of representation of vulnerability that flips the script in the way that feminist pornography is doing.
Thank you. I think it's really interesting. I also think that scientists I think we all might have, but I mean, a lot of people don't feel comfortable being vulnerable. And so I wonder sometimes if some people know the tools are there, but are like purposefully not reaching for them. You know what I mean? But I really appreciated this. Thank you so much.
Yeah. Yeah, that's really well put. I think I think part of what feminist pornography is doing so well is surprising the viewer with that new readiness to acknowledge vulnerability, right? So how can science do the same? Perhaps by getting scientists to identify with their instruments, right?
David?
Thank you for such an insightful and wide-ranging talk. So something that happened parallel over the period described is the immense development of statistical science and more recently of computer science. So how do those developments factor into the development of the measurements of vulnerability? And I did say measurements plural.
Right. So part of this 20th century history is the systems theoretical meaning of vulnerability, which is developed to apply in large part to large technological systems, including computational systems, and to operationalize the calculation of vulnerability by those computational systems. So that is, very much part of this history. I think what's happening now is that researchers are trying to translate meanings of vulnerability that come out of different genealogies, right, into those same computer systems and models of the future. And that's where a lot of the current friction is coming out. I don't know if that's where your question was going.
More particularly of very statistical methods. For example, you have the revolution of statistics becoming mathematical statistics, while developing a high abstract and often interesting geometrical theory based on very practical experimentation. And it also has things as factor analysis, which could get you into causative factors, but also possibly many spurious sort of explanations. And a very powerful set of tools that you really have to understand. And of course, their power developed even more once you have the revolution of digital computing. So how does that specifically affect vulnerability decisions?
Yeah, I mean, yeah, I would add catastrophe modeling more recently, to that set of tools. And I would say that, I mean, let me venture that one outcome of those developments is the hardening of the ideal of invulnerability, right? I mean, these are tools that have given a great deal of confidence to large corporations, to the insurance and reinsurance industries, to a lot of wealthy people in the face of potentially catastrophic developments like climate change.
My understanding of the various sciences, including physical sciences, they should be developing humility from if they're really a real understanding.
So that is a very, very interesting question. And I think that, so if you take a theorist like Helga Novotny, I think, much of her career has been spent trying to spin those tools in precisely this way as a science that should bring home to us epistemic humility. And so this is part of, this could be a very interesting part of, I think, this research project to understand that dialogue. And, as Jill put it, the way in which people don't want to recognize their own vulnerability within the complexity theory community.
Thank you.
Jamie?
So wonderful, fascinating stuff. And there was a point where I've got a question about moral. If no other questioners come up, I can ask a question about moral hazard and adaptation. But the larger thing is about masculinity and vulnerability. And of course, I assume that the polar opposite of vulnerability would be self-reliance and that kind of belief of reliance and individualism, the rugged individualism. So what does this say for ideals of masculinity, which of course is a going concern at the moment? Canada's most famous public intellectual, sadly not here at this time, Jordan Peterson, for instance. So I'm just thinking about what would a science of vulnerability say about questions like humility, but in particular, what does it say about men?
You're making, I think, a suggestion that really intrigues me, which is that perhaps some of the theorists of vulnerability that I should be paying attention to in the late 20th century are not in feminist theory, but in masculinity studies. That is very, very plausible. And it's not a field that I know well, but I can definitely see the relevance, and I will follow up on the idea.
Thanks.
So although I'm chair, I do want to kind of jump in here with a really quick question. So I wondered, I know that you're speaking of vulnerability in many different ways. So not just epistemic vulnerability, but, affective vulnerability, vulnerability associated with risk and economics and so on. But I wonder if there are any other affective terms that are important for this project. So one that I thought of was empathy. So it kind of follows a little bit closely on what Jamie was talking about, because I wondered if Ingenhousz and, either in the philosophies of nature of the 18th century or in efforts towards climate justice, if empathy is a term that is relevant here.
So I think empathy is a very problematic term. I am really interested in, right, all of these permutations that sensibility takes on moving into the 19th century. Empathy theory, right, being one of them. You know, I think particularly in literary historical studies, there's a lot of evidence that the celebration of the human power of sympathy is a mechanism of class, gender, and racial oppression, that the ability to sympathize is, right, raced as white, and that it goes along with inaction, right, against injustice. And so this is you know, literature that I'm still wrapping my head around. And I think that, you know, part of what the exploration of the friction between sensibility and risk needs to do is to pay attention to the ways in which each of those terms individually is leading to the kinds of problems that our concepts of vulnerability today have created for us. And so I think that, you know, sympathy and empathy is part of that trajectory.
Thank you. Mark?
Yeah, thanks so much for that talk. It was really fascinating. In thinking about the sort of intellectual tools available for studying climate science and what it has to tell us about vulnerability and risk, is there what can you tell us about the story? I guess I'm thinking recently about the story of like who gets to participate in these debates. I mean, there's a public discourse, but then there's the, you know, there's the scientific documents and the scientific advisors, and, you know, not surprisingly, probably many of them come from the physical sciences and come from engineering. And yet, I mean, as your story points out, I mean, then there are also the social scientists who get to participate. After all, there are anthropologists who study what happens after disasters to communities. I mean, there are various, but, you know, at least in my own work, knowing a little bit about sort of the world of elite science and funding and policy advising, usually it's a very small proportion of money. It's a very minimalist integration of scholars who aren't coming from the so-called hard sciences. So I'm wondering what you found about that and whether that helps us to understand what's been happening.
Totally. I've been thinking about your work, Mark, in this respect, because for so long, you know, from 1988 or so until 2010, I would say, the social scientists really were on the sidelines. You know, when the IPCC included social scientists, they really were interested in economists. You know, and the geographers who made such important contributions to the understanding of, you know, the coupling of social and ecological systems were pretty much ignored, you know, in terms of science for policy. I think it's fascinating the way, so between 2012, 2014, what's called the SREX report, the special report on climate extremes, is underway. And I think that is the real turning point. That is when the geographers who have been thinking about the social determinants of vulnerability come together with ecologists and even some physical scientists, and they finally really start to put these pieces of their models together and to address the tensions between them, right? So if you read that report, the tensions are all over the place. There are definitions that never fully get resolved, but it's really fascinating to see them trying to do that work.
Okay, really interesting. And just one person you might contact, if you haven't contacted her so far, is Roberta Miller, who was at NSF, and I believe was at a center for, well, she may be retired now, a Center for Environmental Research at Columbia. And just, I can email you, but she was an important, I bet she would be a very interesting person for you to talk with.
Thank you.
Jennifer.
Hi again. I just had a quick thought and a question. And my quick thought is that I do think that the idea of the digital age and technology and computers and stuff is creating kind of a false sense of invulnerability, and is often sold to us that way from Silicon Valley as something that is going to make us invulnerable. And the whole black box of that very opaquely actually being much more harmful to vulnerable groups, which is something I do in my own research. But my question was, in addition to reaching out to feminist pornography studies, whether you'd found anything useful in critical disability studies, because a lot of what you're talking about in terms of vulnerability being used as a way to dismiss people, used as a way to talk about individual risk as opposed to any kind of collective resiliency, really reminded me of stuff being done in critical disability studies.
Exactly, yes. So I have actually organized a reading group on vulnerability this year. We are engaging with disability studies, and that is definitely, I think, a very important lens for critiquing these mainstream concepts of vulnerability. So much rich critical thinking is coming out of that framework. I agree.
Jamie.
Okay. I was thinking intuitively, I had in Ursula Le Guin's The Dispossessed, I had Chevek's speech about pain that was in there, how suffering kind of unites us all. And that brought me to thinking about Barbara Prainsack's work on solidarity and biomedicine. It's very interesting as a counter to a lot of it came out about 4 years ago with Cambridge, and it's a very interesting counter. Again, it's biomedicine, but it goes against a lot of it reframes a lot of the individualism that is inherent in a lot of biomedicine. So that might be good for your reading group. Okay, big question. So you mentioned the moral hazard argument and adaptation, and there have been arguments that let's bring out a big thing, geoengineering. So there's a lot of discussion, or what do they call it, amelioration. And this is discussed as something that green groups are resisting, not all of them, but many of them, as basically using exactly the same arguments as in the anti-adaptationists were in the 1980s. There should be no research done in geoengineering on those grounds. This is a big, baggy sort of question, but how does vulnerability in geoengineering, or the avoidance of vulnerability, enter in with this kind of thing? I don't know if it's poorly formed. This is why I had it as my second question.
No, that is really fascinating. Thank you, Jamie. I'm asking myself about the comparison you're drawing between the resistance to adaptation research in the 1980s as moral hazard and resistance to geoengineering research. So I think that the resistance to geoengineering research, it's not just a moral hazard. Geoengineering is a hazard, and it's a hazard above all to the most vulnerable, right?
Mm-hmm.
I mean, we know, right, that if one of these schemes comes into operation, that the poor who are harmed by it are going to have no voice in how it is managed. And, that I think is an important difference in terms of the critiques. But I think it might be interesting, I hadn't thought about this, but to kind of take a vulnerability lens to the geoengineering research discourse.
If you want masculinity, I mean, Edward Teller I think he was one of the first. And then one of his, that Harvard meeting at 2008 or 9, it was one of his acolytes who was leading the charge there. And a lot of them were horrified, but a few of them were thinking, well, he's really out there, but maybe it's not so bad after all. But again, as a way of avoiding vulnerability, that could be something very interesting, and combining it with the masculinity. Just a thought.
Right. I mean, because, geoengineering in some ways is acknowledging universal vulnerability at the same time as it's saying, we got this, right?
That's right. Yeah. And then you get imagine not Elon Musk, but one of the Microsoft guy that was really big into it for a while. Anyway, I don't want to take up your, sorry, being called.
So I had another question about your methods. So you gave us a really rich picture of your kind of the theoretical frameworks and tools you've been using for this project. And at the start of your talk, you mentioned, how we're all missing the archives right now, but I'm wondering if you could tell us a little bit more about the interviews you've been doing or plan to do. What kinds of evidence is this project going to engage with?
So this is a question I'm asking myself. I actually applied for NSF funding to create a robust archive on career histories of these individuals who've been working at that nexus between the physical and social science and climate change. And I didn't get the grant. And so now I'm trying to figure out, do I apply again? Do I try to do something less ambitious in terms of archive building? But I mean, one thing that I have to say was frustrating to me was that one response from the NSF reviewers was, we already have archives of climate scientists, oral histories of climate scientists. So they did not even get the distinction that I was making, because I've looked at those archives and they are the physical scientists. And if someone here knows of examples otherwise, please tell me. And I think, the other challenge I face is that I want to think critically with these researchers rather than against them. And so that will, I think, when COVID restrictions allow, I think it will really require much more like face-to-face trust building. I don't think it's something I can do with the Zoom interviews alone. And again, I'm trained as a 19th century historian. I'm not trained to do contemporary history. So some of these skills are ones I don't even know what skills I'm missing, right? In those respects. So part of me is tempted to make this more about the past, taking inspiration from the present, but not so much trying to tell the history of the past 30 years. I'm still weighing that balance.
Thank you. Are there any other questions for Dr. Coen? David.
Also, seeing as we seem to be a little bit short of the questionnaires, I'm willing to jump in again. So this is a very practical one. You just mentioned the challenge of doing your work virtually. Well, next year, there's a pretty good chance that we'll meet again, same time of year, but in person at Toronto's York University. So we're one of the many HPS groups in the world. And what do you think we could do, being what we are, to help understand and work towards action vis-a-vis the climate crisis?
Not meet in person?
Being in person next year.
Right. I mean, there are many ways in which one could respond to that. One could point out that that's going to cost you a lot of carbon emissions, right, to fly everyone to Toronto. You know, so one question is always, how much of Zoom life do we want to preserve, right? When does it work? When doesn't it? Others, I'm not entirely sure what kind of advice you're asking me for. I'm definitely not
programming. Our format is usually have a group of 3 scholars present, hopefully on a related topic, and then we do it again and again. But also we'll be meeting in person with the large umbrella group of the Federation, which has History and Philosophy of Mathematics, Philosophy Association, all sorts of education groups, and so on and so forth.
Great. Well, I think it's fantastic that you want to do something on the theme of climate change. I mean, you might consider inviting some physical or social scientists other than historians to join in the conversation. That could definitely be productive.
Okay. Well, one thing that we actually didn't do this time, largely because of the Zoom, is hold a joint session with another group. And it would be possible with any of the other 40 groups.
It sounds like a conversation for the rest of the participants here.
Thank you for that. Ernie?
Thanks very much, Debbie. It was a great talk. And I wonder the language of vulnerability, the discourse of it. One place that you may already have looked, might be worth looking at, is Cold War talk about nuclear missiles. And, you know, the language of vulnerability, as I recall, is sort of shot through that in the international relations literature. It's like, it really is a discourse, not just a language. It really became a discourse, I think, in that group, and hardening and all this sort of stuff about silos and missiles and subs. And there's a whole sort of, it became a kind of way of thinking. And you wonder, you know, and Jamie mentioned Teller, right? And I just think that there's probably something going on there.
Yeah, no question. And, you know, as I was trying to suggest, when the World Climate Conference in '79 lifted the vulnerability concept to this, you know, operative function with respect to climate policy, the areas in which vulnerability resonated were very far from, you know, sustainable development. And you know, I think one of the important implications, you know, of what you're saying is that vulnerability had these very conservative potentialities. The vulnerability of American society to nuclear attack was a code for justifying all kinds of intrusions on civil liberties, all kinds of you know, surveillance. And so I think that, you know, it's really interesting to see these worlds colliding, right, around talk of vulnerability circa 1979.
Thank you.
Are there any more questions? Okay, if not, I want to thank Dr. Coen again for such a fascinating talk, and for joining us today. And I hope that you enjoy the rest of your day. Ernie, are there more sessions after this?
One more.
Jamie? Yes, the program chair. So hope to see you at some of those sessions. And do you have any announcements, Jamie?
We still need chairs for tomorrow. So we've got a future imaginaries and the one on the morals of measurement, I believe. I can act as a chair for the futures one, but for the morals of measurement, we need one more chair. So just let me know, just email me, and thank you for that announcement. Also a reminder that the AGM is occurring tomorrow at the same time. And it's effectively a plenary session just like this.
Thanks, everyone. Take care.
Thank you all.
Thank you. Bye.